This program explores conspiracy theories, speculative ideologies, science fiction, fantasy, philosophical discussions, and alternate interpretations of reality. Viewer discretion is advised, and we encourage critical thinking while engaging with these narratives. Modern consumer gadgets house transistors as small as 3 nanometers in size. This is an astonishing feat of engineering, given that only a decade ago, in 2012, scientists managed to develop a transistor as small as 0.2 nanometers. To put this into perspective, 0.2 nanometers is approximately the width of a single carbon atom, making it an almost incomprehensibly small scale compared to everyday objects. For comparison, a human hair is about 80,000 to 100,000 nanometers in diameter. This means that a 0.2 nanometer transistor is roughly 400,000 times smaller than a human hair. The ability to work at such a small scale allows for revolutionary advances in electronics and potentially in medical technology. The first-generation Pentium processors, Pentium 1, contained around 3.1 million transistors, while the Pentium 2 had approximately 7.5 million transistors. These processors were relatively large compared to today's standards, given the limitations of manufacturing techniques at the time. The original Pentium 1 processor had a die size of approximately 16.7 millimeters by 17.6 millimeters, resulting in a total area of about 294 square millimeters. Using modern 3-nanometer technology, a Pentium 1 processor could theoretically be shrunk to a minuscule size while still maintaining the same functionality. If the same logic were applied to the 0.2 nanometer transistor, the reduction in size would be substantial. However, rather than a perfect 4,000 times reduction, which applies directly to transistors, a more realistic estimate for the entire processor die suggests it could be reduced by a factor of approximately 1,000 to 2,000 times. This means that a modernized Pentium 1 processor utilizing 0.2 nanometer technology could have an area as small as 0.147 square millimeters to 0.294 square millimeters. This means that a modernized Pentium 1 processor utilizing 0.2 nanometer technology would be 34 to 68 times smaller than a single grain of rice. While true nanobots, machines at the scale of a nanometer, may not yet be feasible due to technological constraints, MicroBOTS, robots at the micrometer scale, are already a reality. A micrometer or micron is 1,000 nanometers, still far smaller than the width of a human hair, which is roughly 80 to 100 micrometers wide. One notable development in microbot technology is the creation of injectable robots, small enough to pass through the bore of a syringe. These robots are designed for medical applications, capable of navigating the bloodstream and delivering targeted treatments. Researchers have demonstrated microbots that can move within a controlled environment and even perform simple tasks such as removing harmful bacteria from a wound site. Some conspiracy theorists speculate that bots exist at sizes very close to the nanoscale, potentially undetectable to conventional observation methods. These theories suggest that such microscopic entities could be used for surveillance, medical manipulation, or even influencing human biology in ways yet unknown. If nanobots were ever to become a functional reality inside the human body, they could theoretically be controlled remotely, possibly even via a smartphone. Given that modern smartphones already have an impressive array of sensors, such as accelerometers, gyroscopes, and biometric scanners, the possibility of them interfacing with microscopic robotic entities is not far-fetched. The convergence of nanotechnology and ubiquitous computing opens up endless possibilities. Whether for medical advancements, human augmentation, or even societal control, the future of microscopic technology remains both promising and ominous. What lies ahead is not just a question of scientific progress, but of ethical considerations and societal impact.